Hey friends, welcome back to the channel. So in today's video, we're going to talk about design patterns. Now, high-level programming languages have been around since around the 1950s, and since then programmers have been using them to solve all sorts of different problems. Over time, programmers have realised that even though the problems are unique, there's often some similarities between the problems and the solutions. They're not exactly the same, so you can't create a library or use an algorithm to solve it. Instead, they would reuse some of the main ideas as a solution for the different problems that they come across. And eventually names were given to these typical solutions, and that is how design patterns were born. So what is a design pattern? If you're struggling to work out the difference between a design pattern and an algorithm, then maybe this analogy will help. So let's say it's my birthday tomorrow and my wife is going to bake me a birthday cake. To do this, she might follow a recipe, and this is going to give her step-by-step instructions on how to bake that cake. The recipe in this case is an algorithm. It's giving you step-by-step instructions on how to bake a cake that you can repeat over and over again to produce the same thing. Sure, you might switch out some of the ingredients to produce different cakes, but these are really just different input variables. As it's my hypothetical birthday, I also want to have a birthday party. Now, if you think about a birthday party in your head, you're probably thinking about balloons and banners and maybe someone with a cake with candles on it coming out. At least that's what you are thinking about now. But everybody's idea of a birthday party is going to be different. There's no set steps to follow, there's no recipe like you have with a cake. Essentially, a birthday party is going to be different for every person, like the problems that we face in software engineering. But let's imagine that you have this amazing superpower that lets you see what everyone else is thinking. If everyone's thinking about a birthday party, even though they're very different, you would still recognize it as a birthday party. The birthday party in this case is a design pattern. It's the concept of a birthday party that can be reused, even if everything else is slightly different. Hopefully that analogy makes sense, but if it doesn't, let's have a look at what the design patterns actually are. In 1994, 4 authors wrote down 23 design patterns in the book Design Patterns: Elements of Reusable Object-Oriented Software. Now obviously that's a bit of a mouthful, it's not something you can talk about at a party, for example, so most people call it the Gang of 4 book. If you've been programming for a little while already, chances are you've probably already used some of the design patterns, even without realising it. Most of them are actually just common sense. I know when I first started looking at them, I recognised them immediately for patterns that I use in my own code, even if I gave them a slightly different name. So we have 23 design patterns, and these are split into 3 main groups. We have the creational design patterns, so these relate to creating objects in your code. We have the structural design patterns, so how we actually structure those objects, especially when they get quite large. And finally, we have the behavioural design patterns that covers the interaction between those objects and their responsibilities. Now you might be looking at this list and thinking, wow, I'm never going to remember any of those. But no one's really expecting you to know all 23 design patterns. But it's worth looking through them all and being familiar with them so that when you do have a problem, you can think, oh, that sounds a bit similar to this design pattern. And then you can go look it up and learn a bit more and see if it applies. And the thing is, out of all of these different design patterns, there's only really 5 that I find myself using over and over again. So let's have a look at those. So the first design pattern we're going to look at is the strategy pattern. Now let's go back a bit to that cake baking analogy. Let's say you love cake so much that you decide to write an application that will give you cake recipes. So let's say you start off with a birthday cake recipe, but later you want to add in a red velvet cake and then a carrot cake. Now you could just do this with if statements and switch statements and add in all the cakes that way. But then you want to add in a coffee cake and a lemon cake and all of these different cakes. And eventually your code ends up more like spaghetti than cake. And it's all going to get really, really messy. And the thing is, the code in your application shouldn't really care too much about which cake you pick. This is where the strategy pattern comes in. You can split all of those cakes into their own classes and have each of them implement the same methods. And then when it comes to picking a cake, all you have to do is run 2 methods, get ingredients and get method. And this is really useful if you have multiple ways of achieving the same thing in your application. Let's say you've got a maps application and you want to provide navigation via walking, via car, via cycling. They're all going to have the same sort of functions, but the actual implementation is going to be different for each of them. This is definitely one pattern that's worth having in your toolbox to help you write clean code. The next pattern that I use the most is the decorator pattern. Now, if you need to extend an object without actually changing the original implementation, then the decorator pattern is one way to do that. Now, I've mentioned the decorator pattern before in my video about Solid, as it's one of the ways that you can make your code open to extension but closed to modification. I'll put a link at the end of the video to the Solid video if you haven't watched it already. Again, this is one of the patterns that I've used without realizing it before. Whenever you wrap a class in another class, you're effectively using the decorator pattern. The way we normally do this is to have the decorator implement the same interface as the component you want to extend. And then in the decorator constructor, we take in that component as an argument. You can then implement the interface and still be able to call the original component, but now you can add in additional functionality either before or after you make that call. Number 3 is the observer pattern. This pattern is something you're probably very familiar with already, even if you've never actually used this pattern before. The observer pattern is used whenever you want to notify interested parties that something has happened. If you're subscribed to my newsletter, The Curious Engineer, then every Sunday you will get an email from me. It's not sent to everyone who watches my YouTube videos or reads my blog. It's only sent to those select few who have subscribed to my newsletter. This is how the observer pattern works. You have a publisher that implements the subscribe, unsubscribe, and notify subscriber methods. You then have a subscriber interface that all the subscribers need to implement to let the publisher notify them. When a subscriber subscribes to a publisher, they get added to an array. And then all the publisher needs to do is to loop through that array, calling the update method on all the subscribers. Now, the next pattern that we're going to look at is the Singleton pattern. Now, when we think about singletons, we think about creating one thing. Of course, we have things like global variables that you can specify and be able to access anywhere in your code. The problem with that is you can also change it anywhere, and that causes lots of different problems. But there are cases where we do need to have a single object and make sure that we have a single object everywhere. Such as if you've got a database that you want to access, you don't want a different connection to the database for every single time that someone needs to use it. The typical way to do this is to create a sealed class with a private constructor. Having a private constructor means that no one outside of the class can create a new instance of it. So you can't do new whatever. You then create a separate method or a property that lets you create an instance of that class. This is then stored in a static variable inside the class. The problem with this code is it's not thread safe. You could have two threads call this code at exactly the same time. They both reach that null check. The instance would be null, and they'd end up creating two instances of the same object. Now, to get around this, we need to have some form of locking mechanism. So we need a way to stop the other threads from accessing the code if one of the threads is already there. So to do this, we have the same initial null check, but then we implement the lock, and then we check again to see whether the instance is still null before then creating it. And this will prevent the two threads from creating separate instances of the object. Another way to do this if you're using C# and .NET 4 is with the lazy type. It's still thread safe, but it uses a lot less code. The last pattern that we're going to look at is the facade pattern. Now, this is one that's essential to software development and everyday life in general. The facade pattern is all about simplicity. We're constantly using different libraries and frameworks, and even though they save us time, they can make our code messy and complicated. And in many cases, the libraries do a lot more than we actually need them to do. Let's say you're making use of a fictional logging library that isn't very well designed. This library can send logs to a file, it can send it to the console, and it can even send you a Slack message. The problem is this log library only has one method called log, and you have to specify with every single request what type of log message it is, as well as how you want to log it. Rather than clutter up your code with all these implementation details, you can create your own logger interface with simple methods that you can use throughout your code. All of this messy code that's caused by this bad library is then just restricted to one class. And if you do decide to change out the logging library, then you only have one place to change it and the rest of your code doesn't need to be affected. So these are the 5 patterns that I use the most, and I know a lot of other developers do too. But there's another 18 patterns that we haven't covered today, and it's worth having a look at them so you're familiar with them. If you have them in the back of your mind, then you might remember at least something about them when you come to solve a problem. There's a great website called refactoring.guru that covers the 23 design patterns from the book and gives examples on when you can use them. It's definitely worth bookmarking so you can reference it later on. If you like this video, as I mentioned earlier, I have a video on Solid as well that's worth looking at. Thank you for watching, and I'll hopefully see you in the next video.